So here in this section we will learn theorem of class 10th of lesson real numbers. So here theorem states that let P be a prime number if P divides a square, then P divided a, where a is positive integer. Okay, here what they have given, P is any prime number. Here P divides a square. They have given this P divides a square. Then we need to prove P divides a where a is a positive integer. Okay, here, so here let we take any a integer. Let a be any integer. So here we will write the prime factors of a as a p1 p2 into p3, okay, into dash dash pn. So a I have factorized, okay, it is nothing but here where p1 p2 p3 dash dash pn are prime factors of a. Okay, now here a square can be written as p1 into p2 dash dash pn into a square is a into a is this one, and into a again p1 p2 dash dash pn. So on multiplying, a square is equals to p1 into p1 square, p2 square dash dash up to pn square. Okay, so here they have given that P divides a square. So here P is any prime factors, or P is P here P1, P2, or P is one of the, here P is one of the prime factor, that is P1, P2 up to Pn. Okay, here they have given, we are given that P divides a square. Okay, they have given that P divides a square. P divides a square. Okay, so here just generally, so if you take any example, so for example, I take one example here. Example. So consider 24. Okay, it can be written as a is any number. It can be written as 4 6 are 24. That is, or 12 2 is 24. Okay, that is 2 into 4 6 is, okay, 2 into 3. 2 2 is 4, 4 2 is 8. Okay, okay, this is 4 6. So 8 8 3 is 24. Okay, now here, so we know that if on squaring this one, okay, 24 square is 576. Okay, 2 square into 2 square into 2 square into 3 square. Okay, so what they have given here, P divides a square. So consider this is a P. So 2, okay, it divides a square. This is a square. Okay, this is a, this is a square. Okay, this is squaring. So here we know 2 divides a square. That is P divides a square. So we also know that P divides a. Okay, so the number, it is a number when it is factorized to its prime factors. So one of them is divides a. Okay, here 2 divides 24, or 2 divides 24, 2 divides 24, 3 also divides 24. So therefore, by fundamental theorem of arithmetic, so we can conclude that, so P divides A. Okay, so then one more theorem there. So the second theorem is, so here prove that root 2 is irrational. So we know irrational numbers, about irrational numbers are nothing but which cannot be written in the form of P by Q. So P by Q is rational. So irrational are not rationals. Okay. So here let us prove this one. So here what we need to prove, this is a irrational. So first what we need to do here, first I take let root 3 is a rational. I consider or I assume that root 2 is a rational number. We assume that root 2 is a rational number. So then it is rational means it can be written in the form of 2 is equals to a by b. That is, it is written in the form of rational number. So because we have taken this is a rational. So here a by b, here a and b are co-primes. Co-primes means these don't have any common factor. It means see 2 by 3. So they cannot divide each other. Okay. So these are co-prime or 5 by 2. Okay. When we take 4 by 6 is 2 ja, this is 3 ja. Okay, this has common factor 2. This is not co-prime. These are co-primes. So here A and B are co-primes. So then, so what we need to do here, I write this as, I just write this is A is equals to, I send here divided by B becomes into B. Root 2 B. Here A is equals to root 2 B. Here squaring on both sides. So on squaring we have a square root 2b whole square. A square is equals to root 2 square. So root 2 square get cancelled, we have 2. So b square is b square. So here we can say that a square can be written as 2 into any number. Okay, it is nothing but a square is a multiple of 2 or a square divided by 2 or 2 divides a. See, a square is multiple of 2 means a is even number. So a even means 2 is divides a. Okay, here therefore we can say that 2 divides a square. Okay, it means a square, 2 divides a square means a square can be written as 2 times of any number because a square is even. Okay, so here a square is even. Okay, so then here this can be written as, okay, I take a as 2 times of any number. Okay, so not a square, a is any number. Okay, 2 times of any number. Then here I will square this one, that is a square is equals to 2k whole square, that is 4k square. Okay, so it is here a we have 4k square. So I call this as equation number 1. I substitute this in 1. Okay, so I call this as 2 in 1. So here a square is equals to 2b square. A square is 4k square. 4k square is equals to 2b square. Okay, or b square here 4k square. So into 2 becomes divided by 2. This is 1 ja, 2 ja. B square is now 2k square. So it is again, it is in the form of this. That is b square is 2 times of any number. That is b square is also what? It is a even number. So here 2 divides b square. Okay, here 2 divides b square. Okay, here 2 divides a square and 2 divides b square means these two are divisible by 2. So it means these are not co-prime here. Okay, but we have taken these are co-primes. So but our assumption is wrong here. Okay, that's why we have taken here rational, but our assumption is wrong. These are not rational. So that's why these are irrational. Okay, here what we need to conclude. So here A and B have common factor 2. So here A and B are not co-primes. So what it is contradiction to our assumption. Okay. So it is contradiction to our assumption. So contradiction means opposite to our assumption, because we have taken rational but this is not rational. Okay. So therefore our assumption is wrong. Assumption is wrong. So root 2 is not rational number. Our assumption is it is rational, but our assumption is not wrong. It is not rational. So root 2 is a irrational number. Okay, so here in third exercise of real numbers, we have root 5. First question is, prove that root 5 is a irrational. We need to prove same as above, root 2. Okay, so let us prove this one. So as previous, we need to take root 5 is a rational number. We need to assume this as rational number. Okay, then it can be written as root 5 can be written as A by B, where A and B are co-primes. Okay, we need to prove it is irrational. That is we need to prove our assumption is wrong here. So here I just write A is equals to, I send here that is root 5b. So this is A is equals to root 5b. So squaring on both sides. Squaring on both sides. Okay, so now here we have A square is equals to root 5b whole square. Okay, A square is equals to square root get cancelled, 5. B square is B square. So it is nothing but here A is a multiple of 5. So A is a multiple of 5 into anything. That is 5 divides A here. Okay. A is a multiple of 5 means it divided by 5. Okay, here. So here we have 5 divides A. Okay, 5 divides A or 5 divides A square, then 5 divides A also. Okay, so then here we have 5 divides A square, then 5 divides A. So it means A can be written as 5 times of any number, because it is divided by 5 means 5 times of any number. Okay, then it is here squaring on both sides. Squaring on both sides. So then here we have A is equals to 5k whole square. A square is equals to 5 square is 25k square. So I call this as equation number 2. I call this as equation number 1. Substitute 2 in 1. Okay, then 2. So here 1 is A square. A square is 25k square is equals to 5b square. It is nothing but b square is equals to 25k square. So into 5 becomes a divided by 5. So then it is 1 ja, 5 ja. Okay, here we have b square is equals to 5k square. Okay, here also b is a multiple of 5. 5 times of any number. B is 5 times of any number means b is also divided by 5. Okay, so that is 5 divides b square. It is nothing but 5 divides b. Okay, then here so 5 divides b and 5 divides a. So it means a and b both are divisible by 5. It means both are not co-primes. So here a and b are not co-primes because a and b have common factor 5. So therefore our assumption is wrong. What was our assumption? root 5 is not rational number, okay, but it is irrational. Root 5 is irrational number. So second question is, prove that 3 plus 2 root 5 is irrational. Okay, so here it is a irrational. We need to prove this one. So let here also, let 3 plus 2 root 5 be a rational number. We need to take it is a rational. So it means 3 plus 2 root 5 is equals to in the form of a by b. So we have taken this is rational. That's why here this has to be taken in the form of a by b. Here where a and b are co-primes. Okay. So and also here b is not equals to 0. Okay. Then here I write down this one as 2 root 5 is equals to a divided by b. So this is plus 3. Here becomes minus 3. Okay. Root 5 here only. So I send 2 into 2 becomes here divided by 1 by 2 a by b minus 3. Okay. So see here on comparing this we know that this here it is C, it is in the form of rational. Okay. So this is in the p by q form. Okay. P by q form. So this is a rational. Okay. Here 1 by 2 times of a divided by b minus 3 is rational. Okay, it means it is rational means it is equal to root 5. Root 5 is also rational. Okay, therefore root 5 is also rational. But in the last section we proved that root 5 is irrational. Okay. So here it came root 5 is irrational. But it is wrong because we proved root 5 is rational. Okay. Irrational. Okay. So therefore what is this given here? It is contradiction because the fact is that root 5 is irrational. This contradicts the fact that root 5 is irrational. So therefore, here it proved that root 5 is rational, but it is contradict to that is root 5 is irrational. We proved in last section. So therefore, our assumption is wrong. So therefore root 5 what? 3 plus, so I write down here 3 plus 2 root 5 is irrational number. So third main question is in that prove that the following are irrational. Okay, first one is 1 by root 2. So here also first what we need to take, let 1 by root 2 is a rational. We need to assume this one as a rational. It means 1 by root 2 is equals to a by b. Okay, so here where a and b are co-primes and b is not equals to 0. So here root 2, 1 by root 2 I just write down. I reverse I interchange numerator to denominator, denominator to numerator. This is root 2 divided by 1 is equals to, so just interchange this one, b by a. So here see, we know that b by a, this is in the form of p by q. It is a rational. Okay. So here b by a is a rational. So it is rational means it is equals to root 2. So root 2 is also rational. Therefore root 2 is also rational. So but we know that root 2 is irrational because we proved in theorem. Okay. So therefore it is also this contradicts the fact that root 2 is irrational. So therefore our assumption is wrong. So therefore 1 by root 2 is irrational. So second one is 7 root 5. Okay, we need to prove this is irrational. Okay, same thing here. So let 7 root 5 be a rational. Okay, so then it can be written as 7 root 5 is equals to a by b. Because it is rational, we have taken this is rational. That is here a and b are co-primes and b is not equals to 0. Okay, then here I just send 7 here, root 5 a divided by, so 7 into there it becomes divided by. So here a by 7b, so this is in the form of rational because p by q form. So here a divided by 7b is a rational. So it is rational, it is equals to root 5. Root 5 is also rational. Therefore, root 5 is also rational. So, but we know that root 5 is irrational. Okay. So, this calculation is contradicts. Okay. Yes, this contradicts the fact that root 5 is irrational. So, therefore here our assumption is wrong. Therefore, 7 root 5 is irrational. Third question is, here also let 6 plus root 2 is a rational. It means 6 plus root 2 is equals to a by b. Here a and b are co-primes and b is not equals to 0. Then here I just write down root 2 here only. A divided by b plus 6 becomes here minus 6. Okay, then here root 2 is equals to, so here this is b is LCM, bija, that is a minus 6b. So now here this is in the form of p by q. It means it is a rational. Here a minus 6b divided by b is rational. So then it is equals to root 2. It is a rational, then it is also rational. Therefore, root 2 is also rational. But we know that root 2 is irrational. Okay, this is also contradicts. Okay, this contradicts the fact that root 2 is irrational. Therefore, our assumption is wrong. Our assumption is wrong. So, 6 plus root 2 is irrational, not rational.